Hi, hello everyone. Welcome back to Akki-Vikki Math. This is Akshaya, 6th grade. Let us solve this problem today, which is appeared in RMO. Okay, let ABC be a triangle. Let D, comma E be a point on the segment BC. So let this point be over here D, and let this be E, such that BD equal to DE equal to EC. Have BD equal to DE equal to EC. Let us label it as some X. So if BD equal to X, then DE is also X and C is also X. Let F be the midpoint of AC. So we have this is the point F, and the side F is the midpoint of AC. So these two are also equal. Let DF intersect AD at P. So we have BF intersects. So this is BF intersects AD. AD. So this is AD at the point P. So let this point be P now. And AE in Q. Now let us draw AE. Just from here, this is the point E. So we have this point equal to Q, respectively. Determine BP by PQ. Okay, before solving this problem, let us take a look at this ABC and let us draw the three sibiants of this triangle. A sibiant means nothing but it is not a perpendicular bisector or angle bisector or altitude or a perpendicular bisector. Like it is just any line from the vertex to the opposite side. So let us draw from A to BC and from B to AC and from C to AB. So these are the three sibiants of the triangle. So let this point be D, then this is E, and let this be F. And now let this point be some P. Now let us find what the ratio of the areas of ABP divided by ratio of areas of ABP divided by BCP. And now let us find what this ratio equals to. So this is the triangle ABP. We can say ABP is equal to AEB minus APE over here. We have ABP equal to ABE minus this minus APE. And similarly, the same rule for BCP also. So this is BCP. We can write BCE minus PCE. So we have BCP equal to BCE. BCE minus PCE. PCE. Now let us substitute these both values into this ratio. So we can write this corresponding ratio as now this ratio equal to ABE minus APE. APE whole divided by this one BCE minus PCE. PCE. And now we have to find what this ratio equals to. So we have ABE. This is ABE. And now we have ABE and BCE. These both have the vertex B as common vertex, and the bases of these two triangles AE and CE are lying on the same line, which means the vertex B is lying on the parallel line opposite to the bases. So the perpendicular distance between these both parallel lines is always equal, which means we can say the altitude of these both triangles, the length of the altitude is equal. So we can just say the areas are also equal. No, not equal. The ratio of the area is equal to the ratio of the bases. So we have ABE divided by BCE. BCE equal to AE by CE. AE divided by CE. And similar way for APE and CPE. So let us write it like this similar way only. So APE whole divided by CPE. CPE. So this is also equal to AE by CE. AE divided by CE. And we can get now from this, we got these both triangle ratios. So now from these both triangle ratios, we can write, we have ABE equal to ABE. ABE equal to So from this ratio we have it is equal to AE by CE into BEC. AE by CE, AE by CE into BCE. Area of triangle BCE. Now this is ABE. Similarly, we can write APE also. APE. APE equal to, this is equal to AE by CE into CPE. AE divided by CE into CPE. CPE. Now let us substitute these both values into the required ratio what we need. Over here, let us substitute them. So we have AE by CE into AE by CE into BCE. BCE. This whole value minus this value. Again AE by CE into a CPE. CPE. And now in this is whole divided by again BCE minus PCE. BCE minus BCE minus PCE. PCE. Now we have in these both values AE by CE, AE by CE. So we can take AE by CE common and we can write AE by CE, AE by CE into BCE, BCE minus CPE, CPE. This is the numerator and the denominator remains the same. BCE minus PCE. PCE. And now we have BCE minus CPE, or here also BCE minus PCE. So these both are equal. We can just cancel these both. And we got the value of AE divided by CE. AE by CE. So the corresponding ratio of the triangles ABP divided by BCP equal to ACE. Now we can write the similar in this similar way. We can write for other two pairs of triangles in this triangle. So we can write this is ABP and BPC. We have this is AE by CE. Now the other two are APC divided by BPC. Like that we have other two triangles. So ABP by BPC. AE by CE. Now we will write APC divided by APB. APC by APB. Let us write this one more one, which is APC divided by APC divided by APB. Now we have this value equal to, wait. Now we have this value. This is APC by APB. CD by BD. CD by BD. So this is CD by BD. CD divided by BD. And now let us write the one more also, which is BPC divided by APC. BPC by APC. BPC divided by APC. And now BPC divided by APC. Now this is equal to, again, the bases are, we have this is BPC by APC, BF by FA. BF by FA. Okay, this value equal to BF divided by FA. Now these are the ratios of the triangles in the main triangle by the Sibians. Now we got all these ratios. Let us write the product of them. So which is first one ABP by BCP. ABP by BCP into this one APC divided by APB into BPC divided by APC. And now we have this corresponding values equal to, the first one is AE by CE. So now we have AE by CE into, second one is CD by BD. CD by BD into third one BF by FA. BF by FA. And now in this product at the left hand side we have ABP. So we can cancel, and APC cancel, BPC cancel. So LHS is equal to 1. This value is equal to 1 and RHS will remain the same. This will remain the same, so we can write it as it is, which is AE by CE into CD by BD into BF by FA. So we have the product of AE by CE into CD by BD into BF by FA equal to 1. So this is the value of the product, and this condition is called the Sever's theorem. This is called Sever's theorem. Sever's theorem. And now, how with the point of concurrence of Sevians, we can prove that by using the Sever's theorem. If we have this condition is if this condition is in the triangle by the triangle, then we can say that the Sevians of the triangle are concurrent. If not, then they are not concurrent. Now let us get back to the question. Let us solve the question. So now they are asking to find BP by PQ. BP by PQ. BP by PQ. Okay. And now this is BP and by PQ. Okay. Now let us solve it. So we have ABQ. So by the sequence again, we can say let us connect C to Q to AB. Let us connect that line first from C to Q to AB here, and let us also connect from E to P to AB. So this point, let this point be R, let this be S. And now we have again by the sequence of the triangle ABC, we have BF, CR and AE. These all intersect at the point Q. So again we can write ABQ divided by ABQ divided by CBQ. CBQ equal to AF by CF. AF divided by CF. And we know that F is the midpoint of AC. So this is equal to 1. You can say this is equal to 1. Which means we can say the areas of the triangle ABQ and this is equal to CBQ. CBQ. These both areas are equal. And in this similar way, let us take the triangle ABE and we have AD, BQ and ES are the sevians. These all intersect at the point P. So again we can write ABP divided by ABP divided by ABP by BPE. BP. Okay, not BP because we don't know the value of AQ by QE. Now we can write APE. 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 ABP and APE. This is equal to BD by DE. BD divided by DE. And DE. We have D is the midpoint of BE. So again, we can cancel this one and get the value of 1. Which means we have ABP equal to APE. APE. We have these both triangles areas are equal and these both triangles areas are also equal. And now what we have to find? BP by PQ. This is BP by PQ. So again, in the triangle ABP and APQ, A is a common vertex and the bases BP and PQ lie on the same line, which means that this vertex A is lying on the parallel line opposite to these bases. So the perpendicular distance between them is always equal. So the altitudes of those both triangles are also equal. So we can say the ratios of these areas ABP divided by this APQ equal to, we have this both equal to BP by PQ. BP divided by PQ. And now just now we have found ABP equal to AP. So we can just substitute this value into this equation, into this ratio. APE divided by APQ. APQ. So this is APQ, this is APE. These both triangles have A as a common vertex. No, we can take P as a common vertex because the bases, if A is the common vertex, then the bases PQ and PE do not lie on the same line. But if we take P as the vertex, then AQ and QE lie on the same line. So P is lying on the parallel line opposite to these bases. And we can say, because since the perpendicular distance of between these both parallel lines is always equal, we can say the altitudes are also equal. The length of the altitudes are also equal. So you can write the ratio. This ratio is equal to APE, APQ, AE by AQ, AE by AQ, AE divided by AQ. So in order to find BP by PQ, we have to find this AE by AQ. Now, if we have to find AE divided by AQ, We have AE is also equal to, have this AE is equal to AQ plus QE. AQ plus QE, and let us substitute this value into over here. You can say AE by AQ equal to AQ by AQ plus QE divided by AQ, and we can simplify this. AQ by AQ 1 plus QE by AQ, QE by AQ. So in order to find this AE by AQ, we have to find what QE by AQ is. So we have to find this ratio, which is QE by AQ. And now we have to find, so these are, let us find some triangles with these sides, because these both lie on the same line. So we have AQ and QE, ABQ, BQE. These were triangles, and B is the common vertex, so B lies on the parallel line opposite to these bases. So the perpendicular distance is equal, and you can say the altitude's length are also equal. So we can write the ratio as ABQ. So the ratio is ABQ divided by BQE. ABQ divided by BQE. BQE equal to this. We have AQ by QE. AQ by QE by QE. And now we want the ratio, the what these areas ratio are also equal to. So BQE. This is ABQ and this is BQE. Now we have in the triangle BQC. The triangle BQ is also inside this triangle, and these two triangles have the common vertex Q, and the bases for that vertex, the bases are BE and BC, which lie on the same line. So again, Q is lying on the opposite the parallel line opposite to these bases. So the perpendicular distance between them is equal. The length of the altitudes are also equal. So you can say BQE divided by BQC. BQE by BQC. BQE by BQE divided by BQC equal to, this is equal to BE by BC. BE divided by BC. BE divided by BC. And now we have BE equal to, so here we have BE equal to 2x, BC equal to 3x. We can put those values. 2x by 3x. 2x divided by 3x. X. We can cancel them to get the value of 2 by 3. So we have 2 by 3. BQE divided by BQC equal to 2 by 3. From this, we can get the value of BQE. We have BQE. BQE equal to 2 by 3 into BQC. BQC. We can substitute this value into this ratio to get the value of A BQ divided by this value 2 by 3 into BQC equal to AQ by QE. AQ by QE. And we have ABQ and BQC. At the start we have proved that these both areas are equal. So we can cancel these both areas because these are equal. And we got this is equal to 1 whole divided by 2 by 3. AQ divided by QE. And we can write this is also equal to 3 by 2. So you can just write this is equal to 3 by 2. We have AQ by QE. AQ by QE. AQ divided by QE equal to 3 by 2. 3 by 2. And the ratio we need is AE by AQ. AE by AQ equal to, so you can write AE by AQ equal to, if we consider AQ equal to 3P and QE equal to 2P, we can say AE is equal to AQ plus QE, which is 3P plus 2P, 5P. 5P divided by AQ equal to 3P. And we can cancel P to get the value of 5 by 3. So the value of AE by AQ equal to 5 by 3. If this is equal to, so this value equal to 5 by 3. And we have found this to get the value of BP by PQ, the required value. So we have this BP by PQ equal to 5 by 3. So this is equal to 5 by 3. Hence the required ratio equal to 5 by 3. Okay. Okay, now the concepts we have used in this question are, first, the area of the triangle. area of the triangle. Area of triangle. And second, Seva's theorem. Seva's theorem. Seva's theorem. Theorem. Now we have used these both concepts in this question. So for better understanding and practice on these concepts, don't forget to like, share and subscribe. Then follow our class. If you want better understanding and practice on these concepts, follow our classes. The link is in the description below. Don't forget to like, share and subscribe. Bye bye.